What's going on, guys? Welcome back. Hope you're doing well. In this video, we're going to be talking about the concept of loops in computer programs. So let's go ahead and take a look at a definition. It's an instruction that continually repeats until we want it to stop. So essentially, this can help us perform tasks repeatedly more efficiently, leveraging the power of computers, right? And we can also use this to iterate through data structures like arrays and dictionaries. And we'll see examples of all of these things once we hop into the code. Before we do that, I want to give you guys some real-life examples of loops so that we can better understand the concept. First off, let's imagine a teacher that's grading a stack of tests, right? She has to go through each individual test and perform the same operation on each one. She has to grade each test. She starts at the beginning and ends when she gets to the last test. So she repeatedly performs the same task over and over again. And you can imagine how a computer could do that much faster than a human being, right? Imagine you stick that into a computer. The computer could probably grade 30 tests in a matter of seconds, where a person might take hours to do that, okay? Another example would be like a washing machine. So imagine you got a pile of dirty clothes that you want to wash. You put them into your washing machine, select the desired cycle, and let it do its thing. The washing machine is going to repeatedly agitate those clothes over and over again until it's, ready to stop and the clothes are clean. In this case, the washing machine is the loop, and the clothes are the tasks you want to perform repeatedly. Another example would be like someone stuck in a time loop, right? Imagine they are continually repeating the same day over and over again. At minute 0, they start their day. At at hour 24, the day starts all over again. And then they just keep going and going and going. And hopefully at some point that loop breaks and the person stops being in the time loop, right? But essentially the key here is repetition. So let's go ahead and talk about the first type of loop we're going to be working with of two types, okay? We're going to be working with something called for loops and while loops. We're going to start off with for loops. So basically a for loop runs a set number of times before stopping. We define a range with an upper and lower bound to determine the start and end points of this loop. So if we go back to our example of the teacher grading papers, she starts at paper 1, and if there's 30 kids in the class, she stops at paper 30 or test 30. So we have to define the start and end points of our loop. The number of times the loop will run is the upper bound minus the lower bound. So, pretty simple. If the teacher has to grade 30 tests, the loop is going to go from 1 to 30. That loop will run 30 times. So this is what the loop is going to look like in our code, guys. So there's a lot to unpack here. Let's go ahead and get started. So in this case, the I represents the iteration of the loop we are on. It begins at the lower bound and increments by 1 after each iteration of the loop completes. This repeats until we reach the upper bound. So in this case, this 1 through 10, 1 ... 10 represents our range of values. We're going to go from 1 to 10. Inclusively, right? So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times this loop will run. At each iteration, this I guy represents the iteration of the loop we are on. So first off, it's going to be 1, and it's going to perform whatever code we put inside of these blocks. And then once it gets to the end of that block, it's going to go and repeat again. And then I will be 2. And then after it runs the code, I will be 3, 4, 5, until it gets all the way up to 10 and stops. So this is a visual representation of how these loops will work. So basically, while the loop is running, it's going to ask, are we at the last item in the range? No. Okay, continue loop and execute code. And then it's going to go and ask that question again, until it gets to the last item where it says yes, and then it's going to exit our loop. So that's a visual representation of what a for loop is going to look like, guys. Let's go ahead and hop into Xcode now and do some examples of our own and see how powerful loops can be. So with Xcode opened up, guys, let's go ahead and create yet another playground here. So blank playground next, and we are going to call this loops. So let me go ahead and paste my notes in here. So this is just what we had in our, presentation. And let me go ahead and paste another section here for our for loops. So like I said, we're going to be going over two different types of loops, for loops and while loops, and I'll explain while loops in a little bit, obviously in part 2 of this module, but we're going to be looking at for loops first. So let's go ahead and look at an example of a for loop and see how powerful this can be. So let's go ahead and say for I in 1 ... 10 and open up your brackets here. And then let's just go ahead and say print I and run our code. So we can see here that this will instantly print 1 through 10. So what's the alternative we would have to go through to accomplish that same effect, guys? I would have to say print 1, print 2, print 3, so on and so forth. So that would take me 10 lines of code to do what this is doing in 3 lines of code, right? So here is a very clear example of where we can see the power of loops, and we can really leverage the computing power that computers have nowadays. So, you know, if I wanted to go 1 through 100, let's see how fast this prints me out 1 through 100. Pretty much instantly, right? All the way from 1 to 100 in our console. And let me just go through a breakdown of this one more time for those of you who still might be confused. So in our for loop, we have to define a range. Okay, so this is our range. We're going from 1 all the way up to 100 with this ... And I'll explain what this means in a little bit too. And then the I here represents the iteration of the loop we're on. It starts at the lower bound and goes all the way up to my upper bound, which is why we get back these numbers here. It starts at 1, and then on the next iteration, it's 2. The next iteration, it's 3, 4, so on and so forth until we get to 100. So basically what's happening inside of these blocks or these brackets is what my loop is doing 100 times. So I could add in any code that I want here. Okay, I could say print hello, and it would print hello out 100 times. Okay, so it doesn't we don't necessarily have to use this index. You can see that we're getting a warning here, but you know, we can see here that we can just use this loop to perform a task a repeated number of times very efficiently. So we can go more into, you know, what this index guy is in a little bit. We don't always need it. We can just do this to print out anything we want. So if we never actually use it, we can just replace that with an underscore. And that just says, hey, run this thing 100 times. I don't care about the index. I just want to perform some task 100 times. But if I want access to the index, then I want to say print I. Then we're actually using that guy. And there's certain situations in which you want to use it and some which you don't, which we'll go over once we do some more examples. So next up, guys, I want us to go over some different ways of defining ranges, okay? So I want us to, you know, add a print statement here and just add a bunch of lines to create some separation in our program or our console. And let's create another for loop. I want to say for I in 0 up to, but not including 10. So this is just another way of defining a range. I can say print I. Oops, not quotes. That would just print I. It's like I is a string. We want to print this index here. And let's run this and see what that does. Oops, let's make that 10 again. We don't need it to be 100. Okay, so you can see here, guys, that the loop runs the same number of times. Okay, these loops are both running 10 times, but here we just defined a different range. We're going to go over when you might want to use one versus the other, but essentially, if you say ... it goes up to and including that number. If you say ... but less than, it doesn't actually get up to 10. It goes up to 9. And the reason these run the same amount of times is because here we're starting at 0 and going up to 9. So 0 to 9 is the same as 1 to 10. And you guys can see here the difference in the print statements, right? This starts at 0 and goes all the way up to 9. This starts at 1 and goes all the way up to and including 10. If I were to change this to a less than sign, this would now print 1 through 9. And this loop would actually only run 9 times as opposed to 10. So that's just some different ways of defining ranges, guys. And let's grab this guy here and put it below here. And let me just write out an example one more time of what it looks like if you just want to run a piece of code X amount of times. We could say, 0 up to and not including 10, print hello there. And if we run this, it will just print hello there, 10 times. and we don't particularly need the index property there. This loop will just run 10 times. We never need to use this I guide to get access to the iteration of the loop we're on or the value of the range. So we can just use an underscore there. Okay, so now that we've done that, let's go over how we can now iterate through data structures and the purpose of that. This is probably the most common reason for looping or using loops in programming is actually iterating through data structures. So let's go over that now, guys. So as I stated, we can also use loops to iterate through data structures like arrays or dictionaries. This is extremely helpful for things like searching lists or modifying elements within a list. So the loop will start at the beginning of the array and stop when it reaches the end. So this is what it's going to look like programmatically. So imagine we have a shopping cart array. The structure of the loop remains the same, where we say for something in something else, and then we can print this right here. And you guys might be able to guess this would just print each item in the array. So it would print item name is MacBook Pro, item name is AirPods Pro, item name is GoPro. So let's go over a visual representation of what that's going to look like. So it's going to start at index 0, and then go to 1, and then go to 2, and then it's going to end. So let me just do that one more time. So the loop starts at 0, and it will execute the code in the block, which is just printing out the name of that item. And then there's no more code left, so it's going to go to the next iteration. And then I is going to equal 1 at that point. And then it's going to print item name is AirPods Pro, and then it's going to go to I equals 2, item name is GoPro, and then the loop will recognize that there are no items left in the array, and we are going to then exit the loop. So let's hop back into Xcode now and actually write out these examples that we just went over. So go ahead and just add another divider after this guy right here, and let's create our shopping cart array. And it's going to equal, MacBook Pro, AirPods Pro, and maybe like an iPad Pro or something, right? And like I said before, the structure of the loop is the same. So we can say for item in shopping cart, and just open up your brackets and say print item name is item. So let's run this, and then we'll do a line-by-line breakdown of what's going on in the code. So guys, we can see here that item name is MacBook Pro, item name is AirPods Pro, item name is iPad Pro. So that's exactly what we expect, right? Based on the diagram that we just saw. So the loop is going to start here at the first item. It's going to execute this line of code, and then there's no more code left. So it's going to go to the next guy, execute that line of code where item name is going to be AirPods Pro, go to the next guy, item name is iPad Pro, and then it recognizes that there's nothing left in the array. So the loop stops there. So let's talk about this notation that we have here and how it's different from what we saw here. So before, we were creating a range of values, right? Where we're saying, hey, loop through this range of numbers. And in this case, the parameter name that we have here, I, is going to represent a number or an index value. So that when we say print I, this prints 1 through 10. This prints 0 through 9. And this, we don't need I, this just runs 10 times, right? But the key here is that we were defining a range of values and telling the loop when to start and when to stop. Lucky for us, Swift is smart enough to know that we are looping through an array, and it knows exactly when to start and when to stop. So we don't have to explicitly define that range of values. Swift just knows to do that because you're looping through an array. And in this case, the parameter name doesn't represent an index or a number. It represents the item at each particular spot in that array that we're looping through. So in this case, item represents MacBook Pro on the first iteration, this guy on the second iteration, and iPad Pro on the third iteration, right? So you guys can call this whatever you want. You could say for X in shopping cart, print X, and it will do the same thing. This parameter name, you just get to name whatever you want. Up here, we were doing it as I because that's pretty much standard naming convention for when you're looping through a range of values in programming. You could say for I, for index, for IDX for short, doesn't matter. Key here is that you can name this whatever you want, but it should make sense based on what you are looping through. So let's just go ahead and do another example, guys. Let's create like a prices array. 10, 20, 30, 40. And let's go ahead and just say for price in prices. And then let's go ahead and say print price is, and use some string interpolation there like we did before in that module there. Print out our price. And let's go ahead and get another divider in here. And you guys notice my compiler is giving me an error now because it says, hey, we don't recognize X. It has to be item. Just like that. All right, let's go ahead and run this bad boy. And we just get prices 10, 20, 30, 40. Okay. Now what I want us to do, instead of just printing out stuff, I want us to go through like a real life example of something you might use a computer program to do with something like a shopping cart or when you see a list of prices. Let's imagine that we have some coupon that we want to apply to all of our prices and give the user a list of the updated prices after they apply that coupon, right? So let's imagine they have a $5 or a $10 coupon for each item. So let's just go ahead and create another property here. We can say let coupon price equal 5, okay? And now we can go through and say print price with coupon is price minus coupon price, just like that. So this is going to just give each item a $5 discount. So let's go ahead and print that out. And now we can see all of the updated prices with our coupon. And if we were to change this to like, let's say, $10 and run this again, obviously it would just give us the updated list of prices with that $10 coupon. So that's a real world example of what you might actually use a loop to do, guys. And you can imagine that if that had 1,000 items in it, like if that's for a company or a grocery store or something like that, and you want to apply some sort of operation to it, a loop is going to be exactly what you want to do that, because it's going to be able to perform that operation significantly more efficiently than we can writing things out line by line or doing things in a non-programmatic way, like manually by hand or something like that. So another example I want us to go over before we hop into our next section with loops, with while loops, is one more way of looping through an array. So we can say for I in 0 up to, but not including, prices.count. Okay. Then what I'm going to do is say let price equal prices I and print price is price. And let me get my divider in here. And I know that might be a little confusing, guys, but I want us to just run this and see what happens. And we can see here that it just prints out all of the prices in our prices array. So let's go over how this works really quickly, and then we're going to go over the difference between these two things. So they are essentially doing the same thing, but this is going to give us a little bit more capability and functionality, as we're going to see here in a little bit. So guys, this is looping through a range of numbers, the same way we are up here. So we're starting at 0, and then we're going up to, but not including prices.count. So let's break that down. So we see that prices has 4 values inside of it, and this loop runs 4 times. But if you guys remember, programming counting is 0 indexed, or it starts at 0 and it goes from there. So this is something that's a little annoying to have to deal with, but it is what it is. That's just what we have to deal with as programmers, is that prices.count is going to equal 4. But you guys would notice if I try to access index 4 in this array, it would be out of bounds. Like it would be right here, right? This is 0, 1, 2, 3. So we can't access index 4 in this array. So that's why we have to go from 0 up to, but not including prices.count. So this is going to go 0, 1, 2, 3. Okay. And then it's going to stop at 3 because that's where our array needs to end. So here we're looking at an index value. So let me just add something to our print statement really quick. Index is I, and let's run this one more time. So you guys might be able to start slowly putting this together. The price is 10 when the index is 0, price is 20 when the index is 1, price is 30 when the index is 2, so on and so forth. So if you guys remember back from our arrays module, how do we access items within an array? Well, we just have the array name, and then we use our brackets and we pass in an index, right? So in this case, name 0 is Lewis Hamilton, names 1 is Charles Leclerc, names 2 is Max Verstappen. So that's exactly what we're doing here. We're just using a loop to accomplish that, right? So when we say let price equal price is I, on the first iteration of the loop, when the index is 0, it's going to say, hey, go and get me prices at the price at the 0 index from this prices array. And then it's going to store it in this value, and then we are printing it out there. So this is bringing together a lot of the concepts we have previously gone over in this course with array access, string interpolation, and loops now. And I hope it's all starting to come together. So you guys might be like, okay, well, why would I use this and not the other? The other one seems so much easier to do, right? And I don't have to think about the 0, the up to, but not including and all that stuff. Well, here's the use case for this situation. So imagine we wanted to modify this prices array, right? So here we are printing out the updated coupon price, but our prices array stays the same, right? So we're not really modifying anything. So imagine we wanted to perform some sort of operation where after we go through that for loop, it applies the correct number or updates the value of the item that we're looking at in that prices array. So essentially we're applying a coupon and we want the prices array, the new prices array, to have all of the updated prices. Well, here's how we do that. We can go here and say now prices I minus equals coupon price. And then I want you guys to go down here after the loop runs and print prices. And here we can print prices as well. So we're printing prices in 2 places. Let's just go ahead and run this. Okay, so we notice that the price with the coupon is updated in this statement, but prices stays exactly the same. Here, we are just printing out our prices, but now when we print out the new array, look at what happens. It has all of the updated values with the, based on the coupon price that we have, which is $10. And the reason we're able to do that is because we have access to the index here in our loop, whereas here we don't, right? So here, yeah, we're able to see what the updated price is, but we're not actually updating this array because we never actually say prices I or prices at 0 equals this new updated price, right? And that's because here we don't have access to the index, so we can't access the items that we need to in the prices array like we can here. So if you're ever running a loop and you just want to do stuff like this and maybe want to just look at the updated price and maybe display that to a user or something, you can do this. But if you ever want to update the original data structure that you're looping through, this is what you're going to have to do there, right? And there's a couple different ways of doing this. This is just one of them. But I hope you guys understand that concept where here we have access to the index of what we're looping through in our array so that we can ultimately utilize that index to modify the original array. Now, I know that might be confusing. I am throwing a lot of information here at you guys. We are going to get a lot more practice with this stuff as the course goes on and as we start doing some practice problems with some algorithms and stuff like that. But I just want to give you guys some exposure to this so that when we see it in the future, you're not totally blindsided. So that's going to wrap it up for this video, guys. In the next one, we're going to go over one more type of loop, which is known as a while loop, and we're going to cover the differences between that and for loops and do some examples with that as well. So get excited for that, guys. We will see you there. Peace.